welcome back to Math in New Era. Here we are on our second episode on logarithms. It works oppositely to exponents, which we have discussed in our previous episode. Let's dive right in. In a logarithmic expression, we start off by writing log in front, followed by a small subscripted number we call the base. Opposite to an exponential expression, the small number in a logarithmic expression is now the base. The big number is called the argument, but we'll call it the result for the rest of the video to make it simpler. The expression is usually equal to something. We'll refer to this as the answer. The reason behind is because the base raised to the answer is the result when changed into exponential form. Like if we have log base 327, the answer is 3 because 3 to the power of 3 is 27. Note that if you see a logarithmic expression without a base, its base is 10. Similar with exponents, logarithm has also common and uncommon laws, and the base has to be the same for the laws to be applicable. These laws are discussed next. Common law 1. The product rule. When we add two logarithmic expressions together, we can multiply both of their results, such as when we have log base 2 4 plus log base 2 8, we can get log base 2 32, which is 5. It also makes sense because log base 2 4 is 2, log base 2 8 is 3, and their sum is also 5. Common law 2. The quotient rule. Now we subtract two logarithmic expressions together. You can divide their results. Like if we have log base 3 27 minus log base 3 9, we get log base 3 3, which can be simplified to 1. Manually, log base 3 27 is 3. Log base 3 9 is 2, and when subtracted you get the same result. Sometimes the order is flipped, giving you a negative answer. If we subtract log base 3 27 from log base 3 9, you get log base 3 1 over 3. And we know that 3 to the power of negative 1 gives you 1 over 3, so the answer is negative 1. The same answer is obtained when you subtract 3 from 2. Common law 3. The exponent rule. Sometimes the result is expressed in exponential form, such as log base 3 27, which can be represented as log base 3 3 to the power of 3. You can move the result's power to the front of the word log, and it becomes the coefficient. Log base 3 3 is left, which can be simplified to 1. Multiplying that with the coefficient, we get 3, which has the same result as log base 3 27. Common law 4. The change of base rule. When you need to equate two logarithmic expressions with different bases, it requires you to change the base of at least one of the expressions. You can change the base into any positive number you think is suitable to simplify the expressions. You can change the base of a logarithmic expression by writing log base the new base result over log base the new base the original base. For example, we have log base 2 3 plus log base 4 3. You can change one of them to match the other's base. For example, let's change log base 2 3 into having 4 as the new base to match log base 4 3. We have log base 4 3 over log base 4 2, which can be simplified to log base 4 3 over 1 over 2. The fraction below can be multiplied, giving us 2 log base 4 3. Adding that with log base 4 3, we have 3 log base 4 3. There are other laws that can help us solve logarithms faster. They're coming up right next. Uncommon law 1. Reciprocal of logarithms. If we have log base 2 3, it has the same value as 1 over log base 3 2. This can be obtained from the change of base rule we discussed earlier. If we change the base of log base 2 3 into 3, we get log base 3 3 over log base 3 2, which the numerator can be simplified to 1. Uncommon law 2. Logarithms as exponents. If we have a to the power of log base a b, the result is equal to b. For example, we have 2 to the power of log base 2 4, which can be simplified to 2 to the power of 2, which is 4, and the same as the result of their logarithmic power. We also have a to the power of log base c b equal to b to the power of log base c a. If we have 2 to the power of log base 4 16, we can simplify that to 2 to the power of 2, which is 4. Similarly, we have 16 to the power of log base 4 2, which can be simplified to 16 to the power of 1 over 2. Taking the square root, we get 4. And the same answer as 2 log base 4 16. Uncommon law 3. The base is an exponential expression. Sometimes the base can be expressed as an exponential expression. If you see that the base has an exponent or can be expressed like so, you can move that exponent to the front, but as a fraction. If you have log base 2 to the power of 2, 16, you can move the 2 to the front and it becomes half log base 2, 16. Notice that the result can also be expressed exponentially. We have half log base 2, 4 to the power of 2. The power of the result can also be moved to the front as it is. Moving 2 to the front, we have half times 2 log base 2, 4, and the coefficients cancel out, leaving log base 2, 4 equating to 2. There's a different type of logarithm called natural logarithm, which we are going to discuss next. Natural logarithm. A Swiss mathematician called Leonhard Euler created the Euler's constant E, which holds a value of approximately 2.78. Natural logarithms use this number as a base, and it usually is written as ln instead of log. When you see ln, it means to say that the base is e. This kind of logarithm follows the same rules we discussed previously, just like regular logarithms. We've finished discussing about the common and uncommon laws of logarithm, and now it's time for us to answer our quiz question. I hope you've had the chance to try it out, but if you haven't, here it is again. Just like before, pause the video if you'd like to work on it, and resume when you're ready to see the answer. I'm going to reveal the answer as well as the method right after this. We have the information that log base a b over a is equal to 3, log base b c over b is equal to 2, and we're trying to find log base a bc. According to the quotient rule, we can change this form into log base a of b minus log base a equal to 3. We know that log base a of a is equal to 1, so log base a b minus 1 is equal to 3. Moving 1 to the other side, we have log base a of b equal to 4. Change it into exponential form, we get a to the power of 4 equals to b. Singling out a, we have a equals to b to the power of 1 over 4. Now we can do the same thing to this using the quotient rule. Log base b of c minus log base b equals to 2. Similarly, this is also 1. So log base b c minus 1 is equal to 2. Moving 1 to the other side again, we have log base b c equals to 3. Changing it to exponential form, we have b to the power of 3 equals to c. Now we have both the value of a and c. Now we can input those into our equation that we're trying to find. So substituting a into here is b to the power of 1 over 4 as the base, and b remains as b. C becomes b to the power of 3. So multiplying that, we have log base b to the power of 1 over 4, b to the power of 4. Now we know that if the base has an exponent, we can move that to the front as a fraction. So 1 over 1 over 4. Also the power of the result, we can move that to the front as well, times 4 times log base b, b. Now flipping this, we have 4 times 4, log base b of b is 1, so times 1. Multiplying this together, we have 16. And that's how you answer the quiz question. That's it for this episode. I hope you've learned something new about logarithms and how to apply them in solving questions that require several of the rules we discussed combined. Our next episode will focus on the topic of quadratics and discriminants. To get us in the mood, here's our next quiz question. Try it out and comment your answer in the comment section. The method and the answer will be revealed next episode. Thanks for watching and see you next time.